Hello everyone, this is Drew and Yerdri. Today is February the 4th, 2015. We are presenting our project from Dr. Ames GIS class. Our topic is about the old road leads to from Salt Lake City to Las Vegas. So that's the data we use. The starting data is Salt Lake City. The finish point is Las Vegas, and also we download the railroad, river, and existing road from ArcGIS Online, and also the existing lakes. And we download the DM from SRTM, and that's our study study area. Okay. So first, we project all the vector data source into the same projection of the DM data, and after that, let me do this. So that's the projected vector sources, and after that, we perform the buffers on these different vector data sources, and then we perform the conversion. We convert the vector to raster. And this raster are some of our cost surface, right? Also, we extracted the elevation and the slope from the DM raster. So for now, we have six cost surface: lake, railway, road, river, elevation, and slope. And then we calculated the cost raster by linear add all the weighted factor up to one raster. And after that, we calculate the distance raster. At the same time, we got the backlink raster, and we can use this two raster to calculate the least cost path from Las Vegas to Salt Lake City. So we got the list path in raster format, and then we convert the raster to vector. So that's the final list cost path we got. And we used different combination of parameter that represents the different weight between the six parameters. So we have the railway 0. That means we only consider the other five parameter, and O1, that means all the parameter the weight the same. And elevation 0 and elevation 10, all others are 1. And the slope 10, river 10, lake 10, railway 10, and road 10. So we can see we got different results. Okay, so please let Yerji to present the detail on the code.
Hello, I will explain how you can use our least cost path script. There are two ways you can use it. First method is directly from your ArcMap interface, and second method is through command line. If you want to use our tool through ArcMap interface, you go to Arc Toolbox, you locate our toolbox, and you click on the script. In this script, you have different parameters. Folder, that means the output folder where our data is. Then, road weight, railway weight, lake weight, river weight, and slope weight, as well as elevation weight, those are relative numbers or weights, saying how important do you think each factor is in determining the least cost path. So, this is the first way. And the second way is running our tool through command line. Now, in command line, you need to make sure you use the Python interpreter, which is in C, Python 2.7, ArcGIS 10.2. And you run Python exe to launch our script. And you can see there are command line parameters. First command line parameters is the input data folder. Second one is the output data folder. And the last 6 parameters are the weight for road, rail, lake, river, slope, and elevation. Let us run our script. Here we have used the weight 1 for all factors except for railway. And as our script is running, it shows the messages of the progress. We have reclassified our vectors and created the buffer. Now we are processing the lakes and rivers. We combined them to a cost raster and saved the final cost path to a map which is in PDF format. If we want to see our map, it is in our output folder and it's called map.pdf. For any combination of parameters, we can get a different PDF map. As you can see on the bottom of the map, we show the values of factors which were used for the creation of this map. Let us explain our code. We have written our code in Python programming language. We have not used Model Builder to generate the code. Rather, we tried to write it ourselves and understand how it works. Our script is structured into 4 main functions. The first function, create cost layer, is used for processing the vector data, for example the rivers. First we reproject our rivers, second we create the buffer, third we convert it to raster, and last we create a cost raster from this. We can reuse this function for all of our vector layers. The second function is for processing the DEM. We calculate the slope and we calculate the cost layer from the DEM. The third function is for preparing our data. In this function, we call the processing for vectors and rasters and save these to intermediate files. The last function is used for creating our map, setting up the labels, and saving our map in the PDF file. The body of our script is in the second half. First, we need to get the arguments from the users. There is a total 8 arguments which the user can change. User can change these by input in the toolbox or by using the command line. Next, we define the folder where our outputs are stored. In the input folder, it is required that the names of the input are DEM, start, finish, railroads, lakes, rivers, and roads. Now, this part is important, because here we are creating the cost raster. In the next step, we are creating the distance raster and calculating the least cost path. Finally, we are creating our PDF map and adding the least cost path to our map. Let us look again at our results. Each time we run our script, a new folder is created by the script. In this folder, we can find all intermediate files used for calculating the least cost path. This way, we can look into our steps. And we can see the result file map.pdf inside. So, we can put all our calculated paths in one map and compare them. One of our paths stands out. It is the all zero path. Here we set all of our parameters to 0. And it follows the edge of our study area. Do you know why this is? If you want to try out our tool, you can find it on the website github.com. Just search the word least cost path. And the first link shows you the website where all of our code, together with the complete sample data, is available for you to try out. Thank you very much for your attention.